In this video, I'm going to demonstrate a simple technique I use to set up my camera tracking. This is a more procedural technique where the camera can dynamically track an object on the SOP level or on the object level. When I was setting up a scene for a previous video, I noticed that the camera tracking shelf tool wasn't working out for simulations because the simulations were moving the objects in the SOP level. So that's what inspired this video. The rolling cube you see in the scene is a very simple RBD simulation with no fractures. And if you're curious how I created that, I made a supplementary video explaining how the rolling cube works. And I wanted a more dynamic approach into tracking objects. So when I change my scene or simulation, which causes the animated path to be out of sync with the simulation, I don't really want to keep updating the path every time in order to track the object. I wanted a more dynamic solution that would be calculated in real time. Essentially, make it once and just forget about it. Now, as you can see, I have to keep panning the 3D viewport in order to get this to view the cube. And when it restarts again, it goes back to the beginning. So I have to keep panning and tracking the object. What we want to create in this video is a camera that will dynamically track this cube in real time. What I mean by this, our animation is not driven by keyframes and is a dynamic simulation. The camera will track the dynamic object, which is our rolling cube. When we change the RBD simulation, the camera will automatically update the tracking. So let's go back all the way back up. I'm going to start off with a pre-made ground and a very, very simple rolling cube geometry. Now the rolling cube, it's simply just let me turn on real-time playback. It's simply just an animated cube that's rolling on the floor. So this animation is not predefined. It's actually from an RBD simulation. I created a supplementary video that has a brief explanation on how I create the rolling cube RBD simulation, but that's in a separate video. The focus of this video is camera tracking, so I didn't want to go off topic too much. If you are curious how I made the rolling cube, I'm going to post a link in the description for that separate video. Let's go into the rolling cube just for 1 second. Then I put two more nulls down. One for to render, and another one is just for the camera tracking. Essentially, these can be the same because it's the same thing. Just for better organization, I have labeled it differently. I'm using the extract geometry node that calculates a transform matrix. This basically gives me the offset position between two things that I explicitly specify. So let's drop down a extract transform geometry. The extract geometry node can be found right on the object level. So this is the highest level on Houdini's network. Come here, press tab, and just type in extract transform. Drop this down, and we can see that this requires two parameters, the source geometry and the destination geometry. The source geometry is where the object starts from, and the destination is the final position of the geometry. Now, in order to get that, I'm going to create another geometry, just so that we're a little more organized. And I'm going to call this to track. Let's come in here. I'm going to drop down object merge, so I can merge our cube into here. Let's find our rolling cube. So that's this. And I'm going to choose out camera tracking geo. Essentially, I can choose out render as well because in this scene, these two are both the same thing. But for organizational purposes, I'm going to choose this. Like in the future, when you get larger projects, the object that you're going to track may be different from the one that you're going to render. So this is good practice to name it. Separately. Transform into this object. So here's our cube. Let's just play it. Oh, we're looking at it the other way. Okay, let's play it. So, okay, looks like it's working. Now let's put another null down. So this will be our destination geometry because this is what we want to track. What is our source geometry? Where is it coming from? This is the initial position of the cube, right stationary, right at the beginning. this is what we want on frame 1. So we can use a time shift. And come here to the time shift frame. Let's delete this. It automatically comes with a Houdini expression. So let's just get rid of that. Let's delete it. Right click the frame parameter, and then choose delete channels. It gets rid of the green highlighting. So that's what we want. We want frame 1. We want this node. So I'm going to place the render flag on this time shift, and this viewport is going to stay on frame 1. So no matter where I drag this timeline, this cube is not moving. This will be the source geometry. Now these are the two geometries that the extract geometry node will need to calculate the offset position or the transformation matrix. So let's go back up. We can actually remove the render flag from this because we're not rendering this. We only need the data that comes from it. So let's come to the extract geometry. The source, let's find it. Let's go here, let's find it. The 2 track. Now this is source, so let's place it in. Destination, let's come here and let's place 2 track destination geometry. Cool. So let's play it. Nothing is really happening. We don't have how do we use this extract geometry? Now let's place a camera. Let's add a camera down here. And just parent the camera to the extract geometry. By parenting, the camera will follow the positions that the extract geo node calculates. So let's step back for a second. Normally when you parent an object to another object, it'll just follow that object. The child object will follow the parent. However, the extract geo isn't really an object. Is there anything to follow? But there is. We fed in source and destination geometries into the extract geo node. So what the extract geo node does is calculate the offset position between the source and the destination. This is the reason why we needed to use a time shift. So this is why we had a time shift node and in here that locks the source geometry to frame 1. Because we needed to calculate the offset position between this source, which is the initial position of the geometry, to the destination position. So if I move the frame over here, the cube starts moving. The position is different. So there's an offset position between frame 22 and frame 1. Okay, let's move it to 22, and then I'm just gonna put the render flag on frame 1, template that. So you can see actually I should template this and put the render flag here. So you can see that's the initial position here. The cube is rolling away from it. This way, using the extract geometry node, it will calculate the offset position. And that offset position is then used to feed it into this camera. And the camera can pick up that offset position using this parent. So, okay, let's step back for a second. So normally when you parent an object, when you parent a child object to a parent object. So in order to illustrate that, I'm just going to turn all this off. Let's come over here. Let's create a small example. So I'm just going to go parent. Come in here. Drop down, and I'm just going to copy this. This will be the child. Let's come here. Let's call this child. So right now it's sitting right on top of each other. I'm just going to turn this to dark. So it's sitting on top of each other. Let's move the child over a bit. Let's move it in front. Okay. Now let's parent the child to the parent. Okay, let's see what happens when we translate when the parent moves. So let's come to the parent and move it around. It automatically updates the child position. So that's handy. That's something that will come in really handy for using for camera tracking. However, if I'm not, like right now, we're modifying the translate on the object level here. Let me turn this back to 0 and let's go inside this object. I'll switch it to ghost so I can see both of them. Now here I'm going to add a transformation. I'm going to modify this. The same translate. I'm still translating the X position. So I'm going to do this. The child is no longer following the parent. So this parent method here, or this parent functionality, only affects things happening on the object level, on this object geometry level where we translate it here. Okay, it only affects it here. Anything that happens inside the geometry level, in the SOP level, it won't affect it. It won't, the transformation will not carry up here. And it won't, this child will not inherit the position from the parent anymore. So that's why we need the extract transformation. This node will actually bring the transformation from the SOP level up into the object level. So this brings the offset position. So that's the reason why we need this to do, like, we have to add the extract geo. Otherwise, you were probably wondering why, like, if parenting works like this, if the child follows the parent, then wouldn't it make sense if we just parent the camera to the cube? Because the cube is here, it's moving along, and if child follows the parent, so if I take this and I just put it over there, parent it to the rolling cube, wouldn't the camera just follow the cube? Well, okay, let's try it. Now, the camera's not moving. It's not following it because the rolling motion of the cube is happening inside the SOP level. It's happening here. So it's not happening on the object level. In order to bring the offset position up into the object level, we need to use the extract geo. And the extract geo works by taking two parameters, the source and the destination, and it'll calculate the difference between the different positions between the two, and it'll bring it up into the object level. Back to our rolling cube example. Okay, now I'm going to parent the camera to the extract geometry node. Once we parent the camera to the extract geometry, it will inherit the transformation matrix. That's that offset position that this node has calculated, and this camera will inherit all that. So it'll follow wherever it leads it to. I'm going to parent it. Now we still don't see the camera. Even if we go to wireframe, we still don't see it. In the extract geometry, I'm going to unchecked extract rotate because I only need the extract translation. Now this is not very useful because if we go here, and I'm going to open a scene view. I'm going to look the perspective in the camera to see what the camera sees, and we're way too close up into the cube. So we need to pull the camera back a little. Let's zoom out a bit. Now come to the tracked object. First, I'm going to remove the render flag on the extract geo because there's nothing to render here. Let's go to the to tracked object. Now I'm going to add a transform node here. Now, by transforming this does not affect the rolling cube at all because this is a different geometry node. We're in the to track. This node is not even being rendered. So we can do anything to it and it won't affect our simulation. So I'm going to move this back. This back here. see that this is a different way of adjusting the camera on the object level while maintaining the parenting with the extract transform node. Now, in order to move the camera back, I'm going to come to the camera here, and I'm going to just move it back right on this translate. Pull it back until I have a good angle of the entire cube. Okay, I'm going to move it up a bit too, so we can have a better view. I'm going to move even more back. Okay, I think that's okay. Okay, now I'm going to play it. So now we always have the cube in the center of our camera's view. And if we move back here, you can see, remove the ground. Let me make this larger actually. So this is our cube's right here and our camera's right here. So I'm just gonna play it. Oh wait, let me highlight this. Okay. So then this is a bit orange, so it's easier to see. Let me play it now. You can see this is following, the camera is following the cube. Now this is how is the camera moving with the cube? We have used the extract geo node. This node extracts the offset position between these two nodes and applies it to this camera because the camera is parenting off the extract geo. Now the extract geo is just the offset matrix. It's sort of like a matrix that tells the camera where to go, and that matrix only contains the distance between these two objects. So this is incredibly handy for rigging animations and camera tracking. This is a different way of adjusting the camera on the object level while maintaining the parenting with the extract transform node. Now, in order to move the camera back, I'm going to come to the camera here, and I'm going to just move it back right on this translate. Pull it back until I have a good angle of the entire cube. Okay, I'm going to move it up a bit too, so we can have a better view. I'm going to move even more back. Okay, I think that's okay. Okay, now I'm going to play it. So now we always have the cube in the center of our camera's view. And if we move back here, you can see, remove the ground. Let me make this larger actually. So this is our cube's right here and our camera's right here. So I'm just gonna play it. Oh wait, let me highlight this. Okay. So then this is a bit orange, so it's easier to see. Let me play it now. You can see this is following, the camera is following the cube. Now this is how is the camera moving with the cube? We have used the extract geo node. This node extracts the offset position between these two nodes and applies it to this camera because the camera is parenting off the extract geo. Now the extract geo is just the offset matrix. It's sort of like a matrix that tells the camera where to go, and that matrix only contains the distance between these two objects. So this is incredibly handy for rigging animations and camera tracking. Please check out the next video where I expand on this topic and demonstrate how the camera facing direction can follow another object. It's like a staring contest, except the object you're staring at is moving. So the camera face following in the next video is handy if you have a stationary camera in your scene and it's always staring at a moving object that you need to track.